So good morning children. In today's class we are going to calculate the location of null point. Location of a null point. Location of null point from Q1. From Q1. When two charges Q1 and Q2 are positive and are located at a distance of r from each other, and a charge which is a positive test charge is placed in between these two. This is located either near to Q1 or near to Q2. It's none of the business. So where it is located, that is our business. It is located at a distance of x. Suppose this is located here, means from here to here it is x distance. Remaining distance is r minus x. The total distance between Q1 and Q2 is x, and the null point is located at a distance of x from Q1. At a distance of x from Q1. Now we are going to calculate the distance x in terms of Q1 and Q2. Okay. So when this location gives you idea that there is no electric field, means definitely E1 is acting towards right side and E2 is acting towards left side with equal magnitudes. Then only this location is said to be null point. Where E1 and E2 are acting opposite to one another. That is E1 is equals to minus E2, this one, minus E2. So magnitude of this is always equals to, that is E1 is equals to E2. What is the formula for E1? F by Q naught. F by Q naught. F by Q naught. Already in your previous class we discussed that what is a U1. We have a formula for that. That formula I will write directly. 1 by 4 pi epsilon naught. 1 by 4 pi epsilon naught. Q1 by, because it is E1, Q1. This E1 is the electric field due to Q1 away from this. E right side. E1. This is due to Q1. That is why we are writing here Q1 by what is the distance between Q1 and our test charge is x. The distance is x is always equals to 1 by 4 pi epsilon naught, because E2 is equal to 1 by 4 pi epsilon naught. Now this E2 is due to Q2, away from this side. Why this side? Why not this side? Because your positive test charge, which is repelled by this Q2 is on left hand side. That is why your field acting towards the repulsive force direction. That is E2. That is due to Q2 by what is the distance between Q2 and Q Q0? R minus x. Okay. So these two are equal. So 1 by 4 by epsilon naught, both will get cancelled. Look, both will get cancelled. Then bring this r minus x here into numerator, r minus x by x, that is equal to Q2 here divided by Q1. Bring this here. Just interchange this one. A mathematical calculation, simple mathematical transformation. So what will you get? R by x minus x by x. So this calculation, Q2 by Q1. Sorry, here square will come. Square. Then this is also square. Square only. So this you will get 1 by 1. This square will go that side and it will convert into root r minus x. r by x minus 1 is equal to root q2 by q1. Take this minus 1 on right hand side. R by x is equal to root over q2 by q1 plus 1 plus 1. What do you want? You want to calculate x. Just interchange these two. Then you will get like this. R is there. R. This whole term is considered as a single term. That will come to denominator q2 by q1 plus 1. q2 by q1 plus 1 is equal to x. This x will come to the right side. So x is equal to, if you don't understand means you just send me a screenshot and I will explain. This is the distance x. This is the distance x. If you are not able to watch this one, I am telling you, it is a q2 by q1 plus 1. q2 by q1 plus 1. Alright. Now this is the location of null point. Look, this is the x distance from q1 and r minus x distance from q2. This will help you the location of null point when you are placing a charge between two charges. Okay. Now similarly you can calculate this one. What is this one? This one and ante meeku adi that అవుతుంది. Now prepare a notes for this one by drawing this case 1. Case 1. In case 1, how to proceed? Location of null point. ఎలా రాయాలో చెప్తున్నాను. Location of null point between two positive charges. This is your heading. Draw this picture and write. Consider two positive charges q1 and q2 and a distance x from q1 is a location of null point. Then the electric field intensity due to q1 is acting towards the right side and electric field intensity on q2 is acting towards left side due to q2. Okay, so electric field intensity both are acting opposite to one another here at this location. This location is called a null point. Now we need to find out the distance of null point from q1 by writing these two formula u1 and u2 by equating u1 and u2. What is e1? 1 by 4 pi epsilon naught q1 by x square and is equals to e2 is equal to 1 by 4 pi epsilon naught q2 by r minus x whole square. By simplifying this one, you will get x. You will get x is equal to r by q2 by root over q2 by q1 plus 1. So this is the distance of null point from q1. Okay, this is how we need to calculate. Just to proceed the same for second case. That I will now I am going to erase this one. Pause this video and complete this derivation. Now this is our case 2. So in case 2, you are going to calculate again the location of null point when your charge is placed at a distance of x from q2. You can take this charge q0 on this side, because when you are taking two opposite charges, null point will not be between two opposite charges. It is outside of this charge. Okay, either not in between these two, either it is located right hand side or left hand side of the charges. So I took on right hand side. So now what is the distance of null point? From q2? It it is equal to x. And we have kept here a positive test charge, whether it is experiencing a force or not. Since it is placed at a null point, it won't experience a force due to this electric field. Now, this is located at a distance of x from Q2, and this same one is located at a distance of r plus x from Q1. What is the electric field intensity of this Q1? E1. Look, E1. It is a positive charge. It is a positive charge. These two are repelled. These two are repelled by one another. Repelled by one another. So repulsive force is acting towards right side. Electric field intensity E1 is also along the same force. And this Q naught is a positive charge. This is a Q2, which is a negative charge. Negative charge. Observe here. Since it is located in the field of Q2 and this field is negative, so this positive is get attracted by Q2. So the force experienced by Q2 due to Q naught due to Q2 is attractive force, which is acting opposite to this E1, that is a E2 left hand side, which is acting on left hand side. Now we are going to calculate the distance x. Okay. Now I am not going to calculate, you are going to calculate. Now I will write the equation further. Since there is an attractive force between Q2 and Q0 and repulsive force between Q1 and Q0, E1 is equals to one another at a null point. So I will write first E1. E1 is a field due to Q1. That is why electric field intensity is equal to 1 by 4 pi epsilon naught Q1 by, what is the distance between Q1 and Q0? R minus x. From the figure it is R plus x square is equals to E2. E2 is the electric field of Q2. So that is why we are writing the formula as a 1 by 4 pi epsilon naught Q2 by, what is the distance? X square. Now we just proceed this one and you will get a formula. Okay. Of null point. You need to derive it. Okay. In today's class we came to two important points and two derivations. One derivation I explained, second derivation you are going to do. లొకేషన్ ఆఫ్ నల్ పాయింట్. లొకేషన్ ఆఫ్ నల్ పాయింట్ నిన్నటి క్లాస్లో కూడా డిస్కస్ చేసాము, ఈరోజు క్లాస్లో కూడా డిస్కస్ చేసాము. నౌ వాట్ ఈస్ ద మోషన్ ఆఫ్ ఎ చార్జ్డ్ పార్టికల్ ఇన్ ఎన్ ఎలక్ట్రిక్ ఫీల్డ్? ఈజ్ charge will move from one point to another point. If it is moving, what is its acceleration? What is its acceleration? Just 2 points I will tell. Since it is a positive charge, and here it is our test charge Q0. So this positive charge is a Q1. It is this one Q0 is attracted by Q1. So this will act. Sorry. This will repel, and the direction of electric field is this one. This is a E bar and this is a F bar. You all know that E bar is equals to EF bar by Q bar. EF bar by Q, not bar, Q. Q is due to this one is a Q1. Okay, so here implies just a small conversions. Suppose you are taking this as a Q, then what will happen? Magnitude of F is equals to magnitude of E into Q. According to Newton's second law, the force applied on any object F is equals to ma. This A is equals to EQ implies, look, A is equal to EQ by M. This is the acceleration of the charged particle. If it is moving, this is acceleration of the charged particle when it is placed in an electric field. So tomorrow we will calculate V. Else today itself we will discuss that. This is the first one and the second one. Second one, when initial velocity is equals to 0, then final velocity v is equal to, just a simple formula, v is equal to u plus at, we all know this. So v is equal to u is equal to 0 because initial velocity is 0. Acceleration we already came to know, acceleration is equal to eq by m, eq by m, eq by m into t. So v is equal to e q t by m. So this is the velocity of a charged particle. We got acceleration and we got velocity of the charged particle. With the help of these two, you can calculate distance also. Distance also. S is equal to ut plus half at square. Okay. Note this in proper way. So today we discussed the derivations of null location of null point. Two derivations. One I calculated, second one you need to calculate. And to small applications, when a charged particle is basically an electric field of intensity E, then what is the acceleration of the charged particle? We got A is equal to eq by m from Newton's second law, and V is equal to u plus at from kinematics, kinematical equations, first equations. By using that, we got the velocity after time t, the velocity after time t. So tomorrow we will discuss few more concepts. Bye.